The Copernican Revolution. Overview. The Copernican Revolution is a paradigm shift from the Ptolemaic model of the heavens, where Earth is stationary and everything else revolves around it, to having the Sun at the center of the universe. History. Copernicus published the sun-centered model of the universe in 1543. He still assumed that the planets orbited the Sun in perfect circles. Aristarchus introduced the sun-centered universe as early as 200 BC, but it did not last long under Aristotle's influence of common sense. Reasons for the Sun at the center of the universe. 1. The Ptolemaic model was good at predicting the positions of the planets, but was not precise, and over time its predictions got worse. Number 2. Copernicus did not like the fact that the Ptolemaic model had big epicycles to explain the retrograde motions of the planets. This could be explained by having Earth also rotate around the Sun. The triple motion of Earth. Copernicus stated that the Earth was in a triple motion. The three motions involved are daily rotation about its center, annual motion around the Sun, and the conical motion of its axis of rotation. Tycho Brahe. Tycho had an observatory built by King Frederick II to measure the position of planets with high accuracy. At this point in time, the telescope had not been invented, so the observatory was strictly used with the naked eye. The positions Brahe observed with his naked eye were 10 times more accurate than previous observations. Due to only being able to use the naked eye, Brahe was unable to observe any changes in the positions of stars over the year, which led to the belief that Earth did not move. Brahe composed a model that would explain Galileo's observations of Venus's phases without making it necessary for Earth to be moving. In his model, all the planets were represented except for Earth, orbiting the Sun, but then the Sun was orbiting the Earth. This model satisfied all observations because it corresponds to reality. The only issue is that it is viewed from the perspective of someone on Earth. In this model of the Tychonic system, you can see that all planets besides the Earth are orbiting the Sun, and then the Sun is orbiting the Earth. Johannes Kepler. Kepler discovered that by abandoning the idea of circular orbits of planets, we would be able to see the true path of the planets, which is an ellipse. This conclusion was found through the three laws that Kepler had discovered. Kepler's laws of planetary motion. Kepler's first law of planetary motion states, the orbit of each planet around the Sun is in an ellipse, with the Sun at one focus. Kepler's second law of planetary motion. As a planet moves around its orbit, it sweeps out in equal areas in equal times. This means that a planet travels faster when it is nearer to the Sun and slower when it is farther away. Kepler's third law of planetary motion. More distant planets orbit the Sun at slower average speeds, obeying the relationship p squared equals a cubed, where p is the orbital period in years and a is the average distance from the Sun in astronomical units. Galileo Galilei. Galileo was the first astronomer to use a telescope in order to observe the heavens. Galileo made many observations that convinced people that the Sun was the center of our solar system and that all the planets, including Earth, revolved around it. Galileo was able to observe and study the heavens and prove that they were not perfect. He was also able to see other bodies traveling in space such as comets and asteroids. Galileo was able to observe sunspots to prove the Sun was not perfect. He was also able to observe valleys and mountains on the Moon, proving that the Moon was not a perfect sphere. He was able to prove that Copernicus's theories were indeed correct by conducting experiments like dropping an atom off the Tower of Pisa and observing it stop when it hit the ground. This proved that objects, even when set in motion, will slow or stop when outside forces are applied to the atom's motion.